Thank you, Scott. To 3D or not to 3D? That's the question. Let me first introduce you to my organization, Naturalis Biodiversity Center, a new name for a new organization as a result of the merger of the institutions Scott just mentioned. A collection of 37 million zoological, botanical, paleontological and geological objects, so it's natural history only. And you should compare the 37 million to the 60 million Scott just mentioned for the Smithsonian collection, not the 137 million. We have a staff of about 250, 450 volunteers and research fellows. The museum has 9 exhibition halls and only, I say only with all respect to the large numbers of visitors here in Washington, of 265,000, which is still the top 10 in the Netherlands, and in the Netherlands you have to pay to enter a museum. That makes a big difference. And our researchers produce about 200 publications per year. Let me start with a small introduction film we made for our digitization project, I must say our mass digitization project in Leiden.
A long, long time ago, our ancestors traveled and explored our planet. Innumerable varieties of exotic plants, animals, shells, and other natural history specimens were collected for scientific research, all with the aim of better understanding life in all its forms. Collections grew ever larger and had to be indexed. Organisms were identified, grouped together, and named according to their natural relationships. In 2010, 3 institutes combined their collections, making it one of the largest in the world, with 37 million items. The scientific information we extract from this collection is vital in increasing our knowledge of biodiversity. Naturalis Biodiversity Center is the Dutch Center of Excellence for Biodiversity Studies. All the data obtained from research is currently being digitized. In the future, people all over the world will be able to access information that will help the spread of knowledge about diversity among plants and animals. It's a place where scientists can work together to deepen their understanding of nature and where we can all gaze in awe at the wonders of life on Earth.
This is one of the promotion films we have made because the Dutch government, who gave us the money, wants us to promote what we are doing. Because of the merger of the 4 institutions in the Netherlands, we were given $40 million, a grant for collection digitization, integration of the collections and staff, and building of new DNA labs. From these $40 million, 18 million had to be spent on digitization. With a task, we had to do at least 7 million specimens for these $18 million, which means an average of about $2.50 per object, which is not much. We have to collect the metadata for the remaining 30 million objects, and I will briefly discuss that now because it will not come back in my talk. We want to know what we have, where it is, how much it is, etc. So, for instance, we have just finished digitizing or metadating the 100,000 drawers with insects, holding all the 18 million insects we have, up to family, genus, or species level and the numbers in the drawers, so that no longer only the scientist or the collection manager knows what we have and where it is, but the whole organization, in fact, now knows where we have a certain species, how many we have, and exactly where it is in our 20-story high collection tower. And we have to build a permanent infrastructure to continue digitization. This project we are running now is a 5-year project, which will end mid-2015, but it will not stop there. Our staff has to continue in the industrialized way we are now digitizing our collections. Because of the complexity of the process, we have made a number of crucial steps in prioritizing process classification, the digistreets, which I will show you, the use of the data, application, external request, etc. And I will go step by step through the process and what happens in our industrialized way. We had to do this. We had experience with larger scale digitization in the past, where everyone was doing the same work. Everyone was sitting behind a computer with specimens in front of him and digitizing exactly what was there on the labels, and the next person next to him or her was doing the same and the same and the same. And we knew that that would be not enough to reach a price on average of $2.50 per object. It was much, much more expensive. And we had, of course, to cover the $7 million for the $80 million. So we came to a more industrialized process where different people in so-called digistreets are doing different kind of the process. First, prioritization. If you have a collection of 37 million and you have to digitize 7 million, how do you select? We decided that all collections were in fact had to be digitized one way or another. It would be easy to just digitize 7 million insects, but then only the entomologist would be happy, but it would not cover the breadth of our collection, and it would not satisfy the need of the users, both collection management scientists inside our organization and abroad. Some elements of the process of selecting the collections. The scientists and the collection managers were asked to come up with proposals of collections under their study or under their care, which they thought were important for both management work and science. These proposals had to have special benefits, specific benefits for research, collection management, or exhibits. Don't forget the exhibits. This was done online, and a selection where they filled in a questionnaire to score the proposals made by others. The outcome could be manipulated a little bit by the management because of, for instance, policy priorities. But that hardly happened. And the outcome, the prioritized projects, were normally followed, sometimes though in another sequence. But we also kept space of about 20% of the money, of the volume of the project, to be flexible, to change ideas in year 2, year 3, year 4, or year 5 of the project. So there is still 20% underspent for ideas for the coming years, or for projects which come from outside our institution by other institutions in the Netherlands. The money we received, the $40 million US, is part of the money the Dutch government funded every year from the gains they made from the gas, from the natural gas from the Dutch soil. And every year 100 million euros, which is about $130 million, had to be spent on large infrastructural projects for the benefit of everyone, in fact, in the Netherlands, not only for, in this case, Naturalis. So we have space for other organizations, scientists in the Netherlands, to ask for specific collections to be digitized. And one of the things which we are now organizing, and it starts working, starts moving already, is digitizing on demand. I will come to that later, as it is, I think, a new and important asset to what we are doing. That was prioritization. Process classification. We have, of course, been looking at 3D digitization. Every project started with a pilot to see how the most efficient way of working would be for specific kind of collections. 3D, and we did not look outside the Netherlands, because when you move with specimens, you don't want to cross borders. There's a lot of hassle with CITES permits, etc., etc. So we looked first for companies in the Netherlands to see the quality and the price of 3D digitization. And of course, bearing in mind that we had to cover, for an average of $2.50 per object, 7 million objects. 3D didn't work for us 3 years ago. Times have changed, things are going rapidly, as we heard yesterday. But we decided, and we had to decide, for quantity over quality. And of course, quality within the quantity, but quantity, the 7 million, was our first target. We looked at how will you work with the collections. Wet collections are different in handling compared to dry collections. Microscopic slides is another thing, and printed publications, again, is another 2D different thing. So we had 4 groups of collections, which we divided further. And there you see the word digistreets. These are industrial, almost not literally running belts, but it is a series of people working on a specific kind of collection together, all doing different things. So we divided the dry collections, wet collections, the microscopic slides, and the paper work in these different collections. The herbarium sheets, as Scott just mentioned, 2D, and you can do that at a very high speed, as I will show you. The mollusk collection, wet collections, which will turn out to be the most expensive ones, entomology, complex, wood collections, both dry vertebrates and dry invertebrates, microscopic slides, paper, and geology, including paleontology. This is an important one. Decisions we made before we started to work as efficiently as possible. Divide complicated and labor-intensive processes into a series of shorter tasks to gain specialization. Don't have everyone doing the same from A to Z, but divide the work into a series of shorter tasks. Standardize the data entry process by using one metadata standard and central registration system. Limit metadata capture to a minimum needed for collection management and accessibility to researchers. Only capture photographic reproduction of specimens and label information where this has a proven added value. And make use of commercial third parties for digitization where it makes sense. So far, and we are just over halfway of our project, which will stop in mid-2015, this is now the price for which we can digitize objects, and it includes an average of 75 cents per project. And the overhead is the entire project team, that's the software, the hardware, etc., etc. You see a difference here in herbarium sheets in-house, 800,000, and herbarium sheets being outsourced. Why not everything outsourced? Simply because we have to learn it ourselves as well for future collections. We will collect, and we will get from other sources. I will show you a little bit later a short film about the outsourcing of herbarium sheets, where we now reach a number of 33,000 per day. The mollusks were cheap. Wet collections, I mentioned that, are expensive. You can't transport many at the same time. You have to bring them up and down. You have seen an image of our tower, which has an elevator to the top, and the top has the alcohol collection in case something goes wrong. Entomology is slightly more expensive because of all the small labels sticked to the pins of the insects, which have to be removed, have to be read, and have to be entered into the computer. Wood is simple. Dry invertebrates, again, because of the handling of the bigger objects, is more expensive. Microscopic slides is under the price we can afford. Paper is easy. And geology is, we haven't started that long ago. Geology, I expect, will become slightly cheaper than this. So on average, we are here at a very cheap rate for capturing the basic data of collections. One of the things we have decided also on forehand is that we are not going to put all the remarks from the labels in the computer. That's the most arduous task someone has to face. Handwriting is difficult to read, especially the old collections. And there's a lot of information in there, from eye color to it has been collected after the second tree behind the third bridge, etc., etc. So we put in the basic data of species, date of collecting, place, collector, these kind of things, which makes data entry quickly and rapidly. Here an example of our so-called glass street. You see a picture, rather vague, in the middle. The glass street is something we do in front of the public, together with the geology street. So the public is part of, or can be part of the process and see what we are doing normally behind the scenes. We have 10 of these different digitization streets, 9 behind the scenes, or in fact 8, and this combination of 2 streets in front of the public. So the people are having tours or can ask questions themselves. And this works for 7 days per week because, of course, on Saturday and Sunday we have more visitors than we have through the week. And here you see a process which is more than just capturing the data. The slides, and we have about 1 million to go, are collected from the collection tower. They are in the well-known boxes where you keep in glass slides. Every slide will get a unique a barcode, very small. They are photographed in a SET scan, very high resolution, with 100 at a time. We do not do the data entry. I will come to that later, which is done by crowdsourcing. It goes back into the box where the glass slides are kept with a box number, a barcode, and it goes back into the tower with a locality. So each individual slide of the million slides we have is now exactly located in the building, on the floor, in the aisle, in the cabinet, in the box, and we know where it is. Not only the scientist, not only the collection manager, but the organization. Talking about transfer of knowledge, when people retire, this is something you don't have to transfer anymore. The herbarium street, in fact, we have two. One inside with our staff to learn, and one outsourced, with a target of 4 million to do in the shortest possible period. We have recently upscaled. We had a target of 15,000 per day. We have recently upscaled it by having 2 shifts per day, so we work not 8 hours per day, but 16 hours per day, and we also work now on the Saturdays. And we managed to reach, to photograph, to digitize at least 33 scans per day. Everything is automatically checked for quality, and there's a protocol for healthcare. One of the issues we were confronted with, including the Dutch law, which is getting more, and not only the Dutch law, but the European law, which is getting more and more strict on working with toxic chemicals, is that all old, and some countries still use it, herbarium collections have been treated with mercury, bromide, or chloride to prevent damage by pest insects. When you open a box with herbarium sheets, mercury evaporates, and the concentration in the environment can be rather high. So we had to make a lot of adjustments to the space in where we work with this, because so many boxes are open, there's so many sheets are evaporating under your nose, that apart from the equipment using to suck the air and to clean the air and to filter the air, we had to decide that young women were not allowed to work in the herbarium streets. Young women who have the wish to become a mother, to get children, we are not going to make them prone to mercury. So it is especially a man's world where the digitization now is happening, and women of above 45 years of age. This is run by an organization, Picturai, you will see a film, and the work is done by a Polish community, and now that the borders in Europe are open, much cheap labor is coming to Western Europe, and they make use of a large group of Polish people who now live in the Netherlands and work to do this work. And we will manage easily to do our 4 million herbarium sheet in much less than the year and a half we had originally planned for it. That's only the picture of the herbarium sheets. The data entry is done in Suriname, one of our former colonies, where 50 people now work and put in the data from the labels, which you can easily see on the screen from the photos. So that, in fact, the entire herbarium collection is digitized. Data are available for everyone, everywhere in the world. Go back to the process. We have organized, with so many data coming from all sides, the following service-oriented architecture. On the bottom line, you see the tesori with a list of species names from, for instance, the Catalogue of Life, our central collection registration system, species management and identification. This is our online Linnaeus database for species description and e-taxonomy, and the media library number down there. The media library contains all our multimedia data, which includes the scans and the pictures coming out of the processes. On the right, there are the research databases, 4 are illustrated here, but of course, that is many more than this. On top of this bottom layer, you see the application layer. And on top of that, an application layer with our different, the Brahms for the botanic data, the collection registration system based on Atlantis for the zoological data, and other tools for validation for research. The top layer checks all the external requests against our authorized model. Of course, not everyone is authorized to enter, to do, to change, to add, etc. And then the data become available through different, in different ways. What do we do with our data? Yesterday it was mentioned that can we guarantee them for the long future? We work together with Beeld en Geluid, Sound and Vision, which is the National Museum for, as the word says, sound and vision, Dutch television, radio, etc., etc. They are the right place in the Netherlands to house the data. We have the online compressed data on our image server and directly available. And the originals go to Sound and Vision, safe. And it doesn't have to bother us, we only have to pay. And we hope to guarantee what we are doing now for the long-term future. Enrichment. As I mentioned earlier, we put in the basic data of the collections so that we know what we have and what the basic data are. But there's of course much more to do. No, it did not go to enrichment. Let me go back. There it is. This is one of the glass slides from the million glass slides we are doing. And this is on a website of a Dutch organization which helps us to have the data entered through crowdsourcing. Netherlands is not a big country, and the word crowd is maybe a bit too much. Initially, there were a lot of people interested to do this, but we now have really a core group of people who enter a lot, almost employees, but they do it from home. Of course, we cuddle them, we give them prizes when they do more. Every single object has to be entered twice, and the computer looks for the differences between the different people who enter the data. As it is from handwriting, misspellings are easily made. So the computer checks the difference, and in that case, one of the staff members, or in fact, the people we hired for the project, is checking these. For the entire digitization project, for the 18 million, we have hired in total 70 people at the peak of our work. It started slowly. We are now in the second, third, and fourth year peak production. We have 70 people doing all the work, and one of them checks this. We targeted for the first 100,000 of the million to do it as a pilot in the Netherlands. Crowdsourcing now cost us per glass object 70 euro cents, which is about $1. We think it can be done cheaper. And so we are thinking to do the remainder 900,000, not in Holland, but outside. And a lot of countries where you can do that easily now. Think about India, the Philippines, Suriname. Georeferencing is a next step. And we had a discussion 2 days ago with the Smithsonian that we all face georeferencing of localities. And let us not do it all apart, differently from each other, but join forces. Amsterdam exists only on one spot in the world. It's a pity if other museums have collections from Amsterdam, as an example, and we all try to georeference these localities. So this is typically something where we can be very efficient in helping ourselves in getting the data we need in a very cost-efficient way together. Research data will be added here, and I think one bullet can be added, which is three-dimensional objects. As I mentioned, we have piloted it in the Netherlands, but it was 3 years ago still too expensive. So it is a challenge for the companies to make it more industrial for us and cheaper. Not all collections, of course, are suitable. We have heard about the herbarium sheets, which are 2D. Birds and mammal skins, or not necessarily. We have seen the fragile and often unique paleontological collections, which definitely benefit from 3D. And in fact, the same is true for recent osteological collections, skulls from mammals and details of the teeth of the mammals. So there are definitely collections which we would like to add on a large scale to the data to enrich the data we have and add the pictures to the databases and put them on the web. Disclosure. Naturalis follows the CC0, and we want to make everything as much available as possible. Still, not every scientist is happy that part of his collections become available before he has retired. We give him 2 years to work on collections before we make it available. That puts some pressure on them. But of course, we put the data on and through GBIF, our own apps, websites, and whatever will happen in the future. But we try to help as many people with as much data, as many collections as possible. In fact, that was still one of the objectives of the Dutch government giving us the money to make the data, the collections, available to as many as possible. Application. We have seen some interesting things yesterday with 3D fossils, what is possible. This is a 2D scan of one of the 100,000 drawers with insects. First of all, these insects, these bumblebees, were registered at object level. We have targeted for 700,000 insects, and the priority group was the bumblebees, because they're under pressure in the Netherlands, they're under pressure in Europe. Especially the specialized species are disappearing everywhere. You see in the bigger picture, within the picture, an example of a bumblebee with the pin as that gray dot, and under it sticks a very small barcode. We can now read the information from the specimens from the computer screen instead of going back to the collection, go to the drawer, and use your scan reader. So the efficiency is there, you can do and read this from the computer. Another thing that was interesting, we are photographing these drawers with the same machine as we use for the glass slides, the SET-scan, a product from the UK. And there's so much details in these images that our researcher who's working on the bumblebees is now developing a computer identification tool based on the structure in the wings of the bumblebees. And that can be done from the computer as well. So we hope to be able in the near future to make a tool that when taxonomy is often disappearing worldwide among scientists for certain groups, that a computer can help us with some groups to identify the species. And the project isn't finished yet. We started about 3/4 of a year ago. We have extended it because the results are so promising. So another way of working, doing research in an efficient way with 2D images from the collection. We are currently making the set scan images of the drawers for which we digitize the objects, but you can see another way of making collections available worldwide. We are planning to do this for all 100,000 drawers with insects, so that entomologists coming to Leiden do not have to spend extra days for first browsing to see what we have, but they can see behind their computer at home what we have. They can inform us on forehand before they come which drawers they want to see, and in fact which species or specimens within the drawers they would like to study. That will make us work much more efficiently. As I mentioned earlier, the metadata for the other insect drawers is at family, genus or species level and the numbers we have. So we know what we have, where it is, and we can deliver photographs. External requests. I mentioned in the beginning digitization on demand. We now have formed the basis, the data for our collections. We will not go beyond that unless there is a specific request. We are not going to digitize the other 30 million objects we have in our collection at the object level. But if someone wants to have the data, we can do it for a very cheap price. And that is true both for our own scientists in our organization and for scientists abroad. If you want to have, like recently happened, the data of all our 13,000 South African bumblebees, we could deliver the data for a very cheap price to the university in Cape Town without anyone from South Africa having to come over, to stay in a hotel and to do it himself. It benefited for us because the South African bumblebees were not prioritized. It was the European bumblebees we are doing. But because of this, South Africa had for a very cheap price the data of 13,000 bumblebees, and we had digitized another part of the collection which was not prioritized. So it was really gain-gain situation. And you see that happening now more often. And the same is true for me with 3D objects. If scientists or exhibits want to have 3D images of objects and they have seen them on a 2D illustration, we know what it will cost, and I hope it will be cheaper, so we can digitize, deliver on demand. And that will be a way to further digitize the collection in a retrospective way. We are, of course, going to digitize everything that now comes into the museum from expeditions we are going to do. But now the scientists in Leiden, they know that if they go on an expedition and they make a project proposal, they are not only going to budget their hotel, their flight, but also to digitize that what they bring in, or that what they want to have from the collection, which we already have. That means that it doesn't put extra pressure on the collection managers, but you can hire for the money you get someone, as we do now with the 70 people, and he can do it in a week, 2 weeks, a month, 2 months, how big the collection is that needs to be digitized. So that puts away the pressure on the organization, and it delivers the data in a quick and efficient way. The project will stop mid-2015, and for us it is a challenge, and one of the objectives of the project to, when the project organization stops, to get it into the organization so that we all work along the same standards we have now developed and rolled out in the organization. And I would like to add another challenge here, and that is for the companies who showed us their possibilities with 3D digitization. Upscale it to an industrial way, make it cheaper and cheaper and cheaper. And next time we will be talking about 3 digitized collections, 3D collections here, to help us. We are a potential client, and I think there are a lot of natural history museums and other organizations which are potential clients to do large-scale 3D digitization in an industrial way and make it as cheap as possible. Thank you for your attention. There is some time left, I heard, for questions, so I can't see you because of the lights shining, but If you have questions, please.
Hi. Hello. Okay. My name's Claire Brown, and I have just a small technical question. When you're outsourcing the data entry, what happens with language barrier? What language are these records written in? And if you send them to Suriname, do people speak the proper language in order to read them?
The collection is outsourced within Leiden in another building. So we move 500, 600, 700 boxes up and down every day. The images become available in Suriname. When people are digitizing collections, they don't necessarily have to speak the language of the country. In fact, we often see that that is hampering the registration of data, because people start to interpret, see a misspelling, and correct the misspelling, which doesn't mean that it's correct. So it is even preferable to do it in a country where they do not speak your own language. Send it to India, send it to the Philippines. In this case, it is Suriname, because the organization had a link with Suriname, and a lot of people in Suriname speak, of course, Dutch. But it can hamper. We have, in our previous digitization projects, too many people were interpreting data, correcting data, and we had to do it all over again. The data we enter into the computers are as it is on the label, without any interpretation. If it's wrong, it's wrong. There's a beautiful example. Alkmaar is a city in the north of the Netherlands. When we had an expedition in New Guinea in the 19th century, the camps in the forest were given names where the people felt at home. So one of the collectors, one of the scientists, gave one of the camps the name Alkmaar. So you see on the labels of, for instance, Birds of Paradise, the locality Alkmaar. And there were people who interpreted that as that is the province of North Holland, the Netherlands, and they added that to the data. That's rather confusing. So you better send these data to the Philippines or to India, and you won't have that problem.